Sushi. Although the thought of consuming raw fish is disgusting to many, I'm absolutely obsessed. My infatuation with sushi has led me down a path of questions. But mainly I wondered, what makes raw fish so safe to eat? The answer lies in cold temperatures. Typically, sushi-safe fish is stored at -4 degrees Fahrenheit for 7 days. This extensive freezing process is necessary to kill off harmful parasites such as tapeworm, roundworm, anisakid nematodes, and flukes. Let's dive into the biology of parasites to see how cold is capable of rendering them powerless. All organisms on our planet can be either eukaryotes or prokaryotes. The main difference between the two is that prokaryotic cells lack a membrane-bound nucleus. Parasites are eukaryotic, which means that they have a membrane-bound nucleus, and metabolic activity occurs mainly in membrane-bound organelles such as the mitochondria. The important thing to remember is that eukaryotes are much more sensitive to temperature. As you might already know, adenosine triphosphate, or ATP, is the form of energy necessary for almost every organism to survive. Organisms must carry on with constant cellular metabolic activity to replenish the ATP that gets continuously used up. Cellular metabolism is essentially a chemical reaction. For a specific input, there's a specific output. The speed or efficiency of the reaction is measured by the reaction rate. When temperature increases, so does the reaction rate. This is because heat acts as a form of energy, helping the reactants move past the energy barrier by increasing the average kinetic energy of the reactants. Imagine yourself rolling a rock up a hill. It's strenuous and you're tired, but at the very end, someone comes along to help you to push the rock over the top. This gesture is similar to the role of heat during a chemical reaction. It gives the reactants that final push to get over the hill and interact. Since we have concluded that cellular metabolism is essentially a chemical reaction, let's take a look at the effect of temperature on the molecular level. Atoms have neutrons, protons, and electrons. The electrons on the outermost shell, or the valence electrons, are the only electrons that take part in the chemical reaction. During a reaction, the valence electrons can be lost, gained, or shared differently to create a new product. An energy source like heat increases the kinetic energy of these electrons, causing the entire atom to vibrate and move faster. This causes an increased rate of collisions between the atoms, causing the exchange of electrons to occur at a faster pace, leading to a faster overall reaction. But this response is exactly the opposite for very cold temperatures. Typically, prolonged exposure to freezing temperatures between -10 to -26 degrees Fahrenheit causes freeze-induced desiccation on the cellular level, or in other words, freeze-induced dehydration. The freezing temperatures used to prepare the fish drastically slow down the atomic movement of the molecules necessary for reactions such as cellular respiration. Fluidity is necessary to continue metabolism, and without warmer temperatures, the eukaryotic cells of the parasite residing within the fish will eventually die. When eating sushi, remember to thank parasites.